Okay, so here we are with 3.7 and 3.8, our last class activity for these two sections. It's class activity number 3, writing equations for lines. So a very important concept, we use lines a lot, and it's good to know how to write the equation for a line. So there are 3 basic types of lines, which means we have 3 basic formulas, so 3 formulas for writing equations of lines. And we're going to take a look at these 3. All right, so let's start with number 1, why not? Okay, so here I go. The first type of line, what is it? Horizontal lines. Ooh, sorry, I didn't mean to shake the table. All right, horizontal lines, the first kind of line. So what does a horizontal line look like? Well, basically, it's a horizontal line. Okay, it can be anywhere. There's one example of a horizontal line in red. Another example of a horizontal line could be the green one. Lots of different types of horizontal lines. Okay, so the equation for a horizontal line is y equals, let me pull out my other color here, y equals k where k is the y coordinate. Coordinate from any point on the line. X, y. So we'd take that y value, and that would be what we'd use for k. Okay, a very simple, straightforward equation. You put y equals whatever number it is from a coordinate point you pick on your line. And we'll take a look at these with examples, but for now we're just doing the intro. Okay, so that was the first kind of line, horizontal lines. What's the second kind of line? Vertical lines. Alrighty. So vertical lines, what's an example? Here's 2 examples. There we go. A vertical line in green. And another vertical line could be anywhere. Pretty much they can be anywhere as long as they are vertical. That's a vertical line. So what's the equation for vertical lines? Well, it's going to be x equals k. Oops, I should have done that in orange. Oh dear, too bad. X equals k, where k is the, now this time it differs from horizontal lines. It's where k is the x coordinate from a point, x comma y. So remember, this is a point on our line. So for example, maybe it would look like this, x comma y. We would take the x value and plug it in. All right, so we've covered horizontal lines and vertical lines. Let's take a look at the next kind of line. The third type, slanting lines. So this covers a pretty broad range of lines. Basically, if the line is not horizontal or vertical, we throw them on in with the slanting lines. So here we go. Here's an example of a slanting line. One example. How about another example? That red one is another example of a slanting line. So basically, not horizontal, not vertical. Okay, because these lines vary so much, their equations are a little more interesting than the horizontal line and a vertical line. Horizontal line and vertical line, pretty straightforward, simple equations. You just pick one number and you plug it in. So for slanting lines, we use this equation. Y minus y sub 1 equals m times x minus x sub 1. Okay, so we call this the point slope form. Point slope form. Okay, good form to remember, good equation or formula if you want to call it. Good one to remember. Should have waited a little longer for that to dry. Oh well. Okay, so really good one to have memorized, please. And yes, I did say memorized. Okay, so what am I filling out here? Well, to fill this out, we need a point, x1, y1, and slope, m. And we plug those in here. My slope, and then the 1 point. So we need a point and a slope for the point-slope form. So it is a little more involved than the horizontal and vertical lines. All right, so there we go, the basic overview for horizontal, vertical, and slanting lines. So let's go ahead and take a look at some examples for finding the equation of a line. All right, so if the problem says, find the equation of a line, or write the equation of the line, here we go. Write the equation, or excuse me, an equation of the line. Okay, and then we'd give you some information. So, before we actually start into these, I'm going to give you the plan I have for all of these, and then we'll go ahead and work on a few problems. So, if we see the directions, write an equation of the line. What is my plan? Here's my plan. Step 1. We're going to figure out what kind of a line is this? What kind of a line is this? Okay, so we'll take a look at the given information and then decide what kind of a line is it. If it's a horizontal line, we're going to use that equation. If it's a vertical line, we'll use that equation. And if it's a slanted line, I know, okay, I need to find my slope and a point. Okay, so it's important to determine what kind of a line we have. The next step. Step number 2. Write down the formula. Slash equation. So for example, if I found out it was a horizontal line, I'd write down y equals k. If I found out it was a slanted line, I'd write down the point-slope form, which is y minus y sub 1 equals m times x minus x sub 1. All right, step number 3. There are 4 steps. Step number 3. Substitute in your numbers. Okay? So, substituting in your numbers, what does that mean? Well, for example, vertical lines, I'd get the x value and sub that in. For slanting lines, I'd find my m and my point and sub those in. All right, last step. It's a pretty straightforward step. Step number 4. Simplify. Okay, step number 4 normally does not apply to horizontal lines or vertical lines because there's not much to simplify. But for slanting lines, we normally use step number 4 because we're plugging in more information, so we do end up needing to simplify a lot of the time. All right, so this is our beautiful plan. Let's take a look at some problems. Okay, so we're going to take a look at 4 different problems. So problem number 1. The directions are write the equation of a line, or write an equation of a line. And here is the problem. And yes, this is a horizontal line. Sorry, I do not have my ruler with me. All right, so write the equation of a line. Go ahead, pause the video, see if you can write the equation of a line. All right, so let's take a look at this. What's our plan? All right, so the plan. Stick to the plan. Step 1, what kind of a line is this? Well, what kind of a line? It's a horizontal line. Okay, so after that, step 2, write down the formula for the kind of line. So what's the formula for a horizontal line? Y equals k. And how do I use this? Well, I'm going to look for the y value. Where's the y value? Right there. Okay, so step 3, substitute in our numbers. So where I see k, I'm going to take that out and replace it with 3. Step 4, simplify. Y equals 3. And we're done. Voila. The equation of a line. Not too bad. Give yourself a little pat on the back. Okay, number 2, same directions. Write an equation of the line. Okay, this is that passes through. Ooh, this is interesting. Passes through the points -2, 5, and -2, -1. Okay, so write the equation of a line that passes through these points. So whenever we see the directions, write the equation of a line. This is the plan that I have in my mind. So the plan is, what kind of a line is this? I'm not quite certain. I'm going to go ahead and draw a little sketch of it. Okay, here's my graph. Let's put in some tick marks. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. First point, -2, 5. 1, 2, 3, 4, 5. Next point, -2, -1. -2, -1. Sorry, I didn't put that tick mark. That's a little off. Oh, interesting. When I draw in my line, what kind of a line does it form? It forms a vertical line. Okay, so it's a vertical line. Another hint we could have looked at instead of having to sketch was, notice the x values are both -2. Okay, so we didn't necessarily need to sketch it. If we had noticed earlier that the two x values were both -2, that would have hinted to us it was a vertical line. Well. Okay, so step number 1, what kind of a line is it? Vertical line. Step number 2, write down the formula. Okay, let's take a look. What's the formula? X equals k. Okay, so we're going to use x equals k. Step number 3, substitute in your numbers. Oh, but we have 2 different coordinate points. But remember, the x value for both of them is the exact same number. It's a -2. So let's go ahead and we're replacing k with -2. And our last step is simplify. So x equals -2. That is the equation of our line. All right. 2 more problems to go. Number 3. Same directions. Write the equation of a line. So write an equation of the line. And here we go. I'll draw a sketch of the line we're looking at. All right, the arrowheads, 2 points, doop, doop. Okay, write the equation of a line. As usual, let's think of our plan. What kind of a line is this? Well, taking a look at it, it looks like a slanted line. Okay, so slanting line. Step 3, what kind of formula are we using? We are using the point form. Sorry, the point slope form. Remember, we need to have this memorized. Okay, so point slope form from our memory. Y minus y1 equals m times x minus x1. Okay, this one is a little more involved. Remember, what do we need to fill this out? We need our slope and a point. Okay, let's see. So I need slope and I need a point. So x, y. Do we have our slope? Not really, so we need to find that. And then do we have a point? Yeah, we actually have 2 points. This point is 0, 3, and this point is -2, 0. So we could use any of those 2 points. It does not matter if I picked this point or this point. They would both be an equation of the line. They might look a little different, but they will graph the exact same line. So if you chose to use the point 0, 3 or -2, 0, both answers would be correct. So I'm going to go ahead and I'll just choose the point 0, 3. Why not? Okay, so we found a point. So I'm going to go ahead and plug that in. My y value was 3, and my x value is 0. So now all I need to do is find my slope. What are ways to find slope? We have rise over run. We have the point slope formula. Sorry, the slope-intercept formula, and then we have that formula for slope. So let's see, we're given a graph, so why don't we just count rise over run? So find our slope, m equals rise over run. So I'm going to start from this point, and I want to go to that point. So I have to go up 1, 2, 3 values, so positive 3. And then run, I need to go 1, 2 points. 2. So my slope is 3 over 2. All right, so since I have room on this paper, let's try find slope the other way so I can show you the fact that two methods can work. So if I didn't want to count rise over run, I could use this formula to find slope. All right, so let's see. I'm going to go ahead and label my points. I'll call these the sub 1s, and I'll call these the sub 2s. Okay, let's plug those values in. So my y sub 1 is 3, minus my y sub 2 is 0, all over. My x sub 1 is 0, and my my x sub 2 is negative 2. All right, let's see what we get. So we have 3 minus 0, which is 3. And then we have 0 minus negative 2. So that double negative becomes a positive. And we get 2. And what do you know? Our slope came out to the exact same number. So this is a good example of how both of these methods worked to find slope. And it's up to you to decide which one was easier for you. All right, so my slope is 3 over 2. And that was the last piece of information I needed to write the equation of my line. So I'm going to plug that in. So taking out m, we're going to replace it with my slope that I just found, 3 over 2. And the last step is simplify. So we have y minus 3 equals 3 over 2 times x minus 0. Okay. Now this answer, the way I've written it and I'm boxing it, is normally perfectly acceptable. But what if I said I want you to answer in slope-intercept form? So we're going to take a little mini sort of side trip and take a look at what that is. So if I said, write an equation of the line, and I put on and answer in slope-intercept form, what does that mean, answer in slope-intercept form? Is that slope-intercept form? Well, remember, what is slope-intercept? Slope-intercept form is y equals mx plus b, which means I need to get y by itself. So when I look at my equation, is y by itself? No, it is not. We have that negative 3 there. All right, so to get this equation, which is normally perfectly acceptable, to get this into slope-intercept form, I need to get y by itself. So y minus 3 equals 3 over 2 times x minus 0. So let's simplify this. X minus 0. That's just going to be x. Y minus 3 equals 3 over 2, and I'll just write 3 over 2x. Okay, so I'm trying to get it into slope-intercept form, which means I need y by itself. So let's move the 3 to the other side by adding 3 to both sides. And I get y equals 3 over 2x plus 3. Is that slope-intercept form? Yes, it is, because y is by itself. We have the x value in the front, and then plus 3. Okay, so as I said before, if I just said, or if the exam just said, write the equation of a line, and it doesn't tell you what form it wants it in, this answer would be perfectly acceptable. Totally fine. But if I say an answer in and I give you a form, like slope-intercept form, you need to go ahead and simplify and get into the form I am asking for. So this is slope-intercept form. Okay. All right, so that was almost the last problem. We only have one more to go. And that'll be it for this class activity. All right, so problem number 4. So write an equation of a line. Oh, that's supposed to be and, not and. Write an equation of the line that, what happens? Passes through the points 2, 6 and 14, 16. All right, so here's our problem. Write an equation of the line that passes through these two given points. Alrighty, so remember, a way we can check to see if it's horizontal or vertical. If the two x values match up, it's a vertical line. If the two y values match up, it's a horizontal line. So let's look at the x values. 2 and 14. They're not the same, so it's not vertical. Let's look at the two y values, 6 and 16. Those aren't the same either, so it's not a horizontal line. So if it's not horizontal and it's not vertical, it's a slanting line. Okay, so slanting line. So since it's a slanting line, what equation am I going to use? I'm going to use point slope form. All right, go ahead, pause this video and try to see if you can write the equation or an equation of the line that passes through the points 2, 6 and 14, 16. Okay, so I'm looking at a slanted line and I'm going to use the point slope formula. So what do I need to fill this out? I need my slope and I need a point. Do I have my slope? No, they don't give us a slope, so we're going to have to find that. Do I have a point? I do. In fact, I have 2 points. They gave me more than I needed. So I just need to pick one of them. It doesn't matter which one I pick. For me, I'm going to pick 2, 6. Why? Because those numbers are smaller. Might as well work with smaller numbers if you can. Okay, so remember, it doesn't matter which one of the two you pick. They're both from the same exact line. I just chose 2, 6 because the numbers are smaller and normally easier to work with. All right, so the only thing we need now is our slope. How do we find slope? Well, we're given 2 coordinate points. So what method would we use to find slope? Well, we'd use this method. M equals y1 minus y2 all over x1 minus x2. Okay, let's go ahead and label our points. x1, y1, x2, y2. And let's plug those in. Go ahead, stop the video and see if you can plug these in and get the same answer. Okay, so plugging them in. Y sub 1 is 6 minus y sub 2 is 16 all over. X sub 1 is 2 minus x sub 2 is 14. So 6 minus 16 is negative 10. All over 2 minus 14 is negative 12. Okay, negative 10 minus, divided by negative 12. Negative divided by negative is positive, so 10 over 12. And then we can simplify this. 10 divided by, well, 10 and 12, we can divide both of them by 2, yeah? 10 divided by 2 is 5. 12 divided by 2 is 6. So, simplified, 5 over 6. So my slope is 5 over 6. All right, so plugging those in, my x and y value, my x value is 2. My y value is 6. And my slope is 5 over 6. So take out that and replace with 5 over 6. Let's simplify that. So we have y minus 6 equals 5 over 6 times x minus 2. And that is an equation of the line. Perfectly acceptable. But what if I said answer in slope-intercept form? Ooh, how would we do that? Okay, so remember, if you left your answer like this and I said answer in slope-intercept form, it wouldn't be correct. So, what is slope-intercept form? Well, remember, it's y equals mx plus b. Okay, so that means I want to get y by itself. So let's take a look at our equation. Y minus 6 equals 5 over 6 times x minus 2. And I want to get y by itself. Now the last problem we worked on, this number here was a 0. So that's simplified. But this time, that's a 2. So first, I'm going to distribute the 5 over 6. Okay? So I'll multiply this in. And what do I get? Y minus 6 equals 5 over 6 times x minus 5 over 6 times 2. And I can put that as a 2 over 1. Let's simplify this. Y minus 6 equals 5 over 6x. Can we simplify? Yes, we can. We can do some simplifying here. So 6 goes, we can take the 2 away. So 2 divided by 2 is 1. 6 divided by 2 is 3. So I'm left with 5 times 1, which is 5, all over 3 times 1, which is 3. Okay, so I just simplified those two fractions being multiplied. Okay, what am I doing? I'm trying to get y by itself. So let's take a look. Is y by itself yet? No. So we're going to get rid of that negative 6 by adding it to both sides of the equation. So y equals 5 over 6x minus 5 over 3 plus 6. Now we might be tempted to say we're done, but we should technically add these two together. So we have 5 over 3 plus 6. How do we add fractions? They need to have the same denominator. What's the denominator of 6? Well, it's technically 6 over 1. So to add these two fractions, they need a common denominator. Let's choose 3. Why not? So let's do the building up property. Multiply the bottom by 3. And when I do that, I need to multiply the top by 3. Got to balance it out. So y equals 5 over 6x minus 5 over 3 plus 6 times 3, 18 over 3. So let's add these two fractions. Negative 5 plus 18 is going to be positive 13. So y equals 5 over 6x. Adding these fractions, we get positive 13 over 3. Now, is that in slope-intercept form? Does this one look like that? Yep, it does. Okay, so that would be if I wanted you to write your answer in slope-intercept form. Whew, that was a bit more work. Okay, so to reiterate, if I just tell you to write the equation of a line and I don't say which form to answer in, this would be perfectly acceptable. But if I say, or if the test says to answer in slope-intercept form, you will have to go through the simplifying process to get y by itself. But the nice thing about this equation is I can easily see what my slope is and I can see what my y-intercept is. So what's the slope? Slope is the number by x, which is 5 over 6. And my y-intercept, it's the number being added, which is going to be 13 over 3. So that's why this form is pretty nice, because we can just pull off the slope and the y-intercept. Alrighty, so that was it for this class activity.